Good afternoon, everyone. I would like to welcome you to the third webinar of the PERFECOAT webinar series. My name is Dušica Banduka. I'm from the nova-Institut in Germany. And within the PERFECOAT project, we are in charge of communication and dissemination. If you haven't attended prior, so the PERFECOAT project is an EU-funded research project financed by the CBEGU. And it's intending to develop bio-based coat and painting ingredients. And in today's webinar, you are going to hear a little bit more about formulation and testing. You are also, of course, kindly invited to join our further webinar episodes, like on June 10th, which is on safety and sustainability, where we will introduce different assessment methods, like LCA, like social LCA, but also sustainability standards. And also we will have a final webinar wrapping on the project in August. This date is to be confirmed, but if you would like to stay on top of it, also please subscribe to our newsletter or also take a look at our website. So today we are lucky to welcome three top speakers from the industry, which is Christine Louise. If you attended the previous episodes, you will already know her. Erin Ellig from Organic Chemia, and also Roland Steinbrücken from the Remas Group. And they will give you some insights on requirements and application testing, but also prior a little bit of housekeeping. If you would like to answer questions at the very end, we will have 20 minutes for questions and answers. So please enter it in the Q&A function and also address it with the speaker. And if you would also like to elaborate a little bit more, you can also raise your hand and we will unmute you so you can state your question verbally. And afterwards, of course, all slides will be made available on the PERFECOAT website. So, and with that, I would also like to introduce our first speaker, who is Christine Louise. And she has more than 20 years of experience in the coating and ink industry. She has been working for Evonik Coating Additives since 2017, and she's one of the technical experts for decorative coatings. Christine focuses in her work strongly on the development of novel additives for decorative coatings, such as surfactants, defoamers, dispensers, but which are also in line with Evonik's sustainability goals. And today she is going to give you an overview of formulation and testing for architectural paints. Take it away, Christine. Looking forward to it.
All right. Hello, everyone. Here I'm going to share and show you what we prepared for you. There you go. Tell me, please, if this is ready. So thanks, Dušica, for the intro. As you said, we'll discuss formulation testing
now we
today.
see on the black screen, Christine.
Okay.
Let's try again.
All right.
Yes.
Of course.
No, there has been no. I think there's like a slight delay. So we saw it for a second and then it...
There is a, yeah, there is then a long delay. Should I share again?
Yes, please.
Sorry about that. How is it now?
Yes, not in presentation mode yet, but in a bit, most likely. Now we go. Thank you.
Okay, no problem. So during this presentation, we'll go through different topics. I'll start with the formulation of paint and coatings to give you some insight on about what formulation is in the lab. And then Erin will follow. He will discuss the testing about wall paint and trim paints. And in the third part, so Roland will continue with the testing of the UV-curable wood coating. So that's the program for today. So I'll start basically right away in the topic of formulation. And as a reminder, maybe from the first webinar, if you attended, I just want to make sure you keep in mind the different ingredients, the main ingredient of coatings, paint and coatings, starting with the binder, solvent, pigment, fillers, and additives. The binder basically is the main ingredient when you start formulating. That's often the first material you will select because it's really important for the performance of the coating that you want to develop. It's allows the film formation and really drives the main characteristic in terms of durability and mechanical resistance of the coating. So it's essential in the selection of material. The solvent are important. Water is part of the solvent as well. You can think of glycols as well. There are also formulations which are solvent free, like the UV technology can be. And the role of the solvent is to allow the processability, really it's necessary to put the formulation together. And an important criteria is that the solvent should leave the coating at the end when it's applied and dry. So the solvent should not be there anymore. The third one is pigments, so powders, particles, which provide mainly the color. So there's a lot of important, lot of challenge around the stabilization of the pigment and the color development, but we'll discuss that. And then comes the filler, another particle present in the coating, which the role is to give a certain body, certain properties, like hiding power. They will also influence a little bit the rheology, so they're also there to contribute to the economical aspect of a coating. They are used especially in the first layer, the sealer or primer.
Sorry to interrupt you, Christine. Are you switching slides?
On slide main ingredient with
okay.
5 square
Okay.
with the pictures. Is that okay?
Yes, of course.
Okay, and now the last one, additives. So there I can talk a lot about because that's where I have the most experience with. And in the formulation of a paint, that's really well, that's where a lot of effort goes into as well. There is really a broad variability of additive that you may need, and not necessarily to formulate a paint or a coating. So you can see here with the substrate and the coating, there is additive you can use to promote the adhesion. They are additive, like we call them defoamer or deaerator, that you use to eliminate the air bubbles, which can be trapped at the surface of the coating or underneath the coating. Then there are additives that we call substrate wetting agent to promote the coverage of the coating onto the substrate. At the other interface, the interface of the coating with the air, there as well a lot of additive can be used to control the slip properties, the leveling, so to have a nice smooth film, anti-blocking properties. And within the coating, as mentioned, the presence of pigments. So there as well, dispersant or pigment wetting and additives can be used to stabilize them. Matting can be a requirement to control the gloss. Then you'll use a matting agent. The rheology control, we'll talk about that as well. And the hydrophobization, also very important for exterior facade coating, for example. So let's look into a formulation itself to really understand what it's all about. This is an example that Erin provided to me. It's an interior matte wall paint. So typically what you could have applied on the wall inside your home. It has an important criteria. It's called the PVC, it's a pigment volume concentration, that gives you an indication of the amount of particles related to the amount of binder that is in the coating. So this one is fairly high. It's a matte paint, so the gloss is fairly low. Here you can see on the right side the table with all the ingredients, quite a few, and there is basically 2 steps to follow. The first step is the grind, followed by the let down. So in the grind, we'll find the pigment as well as a filler. In this case, the pigment is a titanium dioxide, so it's a white paint with different filler and extender, calcium carbonate extender. And there are a whole lot of additives there to help the processing, to disperse the pigment, to eliminate the foam, and to control the rheology. And then in the second step, the let down, there we will have the binder, some solvent, and again, some additive to control the appearance, the defect, and the rheology of the final paint. So this is one example. I have another example of a different paint, a trim paint, that will be discussed also later. This time there is main difference, the PVC is different, it's lower. So that means that the amount of binder is higher compared to the first formulation related to the amount of pigment and filler here. So it's a semi-gloss paint. It's a little bit more glossy than the first one. And also the contribution to the binder, to the resistance. It's a paint that could be applied on the outside, so it needs to be resistant to the weather. For the rest, there is similar type of dispersion, deformer, control of rheology, biocide, like in the same one. Some solvent are added and also will contribute to the film forming and coalescence. I have also some example of UV coating. This time, this one is a sealer. It's typically applied by roller application. So mainly, you've got the main resin, the epoxy acrylate, with some reactive diluent that is fairly reactive with 3 acrylate functionality. There are some extenders and some additives also to control foam and disperse the particle. An important parameter here, the ingredient, the photoinitiator, which are necessary to trigger the reaction under UV lamp ultraviolet. So this is a sealer. Sealer means this is the first layer that is applied to the wood. It's often then followed by the application of a top coat on the top of it. Basically, this one has a lower viscosity. It's really the difference here. It's especially on the chemical resistance and mechanical resistance, as this surface will be, aggressed by, so it needs to be strong and more durable than the sealer. It contains similar ingredient, but more different diluent, reactive diluent, but again, extender. In addition here, matting agent, and again, some additives and the photoinitiator, a different ratio. So this was to give you a few ideas of how paint formulation is put together. But now let's look into some, insight on let's say some of the challenges that can be encountered when you start putting all the ingredients together. So the first step, as I said, the grind. Here we're going to look at a small animation. I hope it starts soon. Basically, when you start the grind, you start with water or solvent and some additive. In this case, this is a dispersant. And then we'll add the pigment and filler to that. So they come into agglomerate. I hope you can see as I'm talking, with some air in between. So it first there's a first phase of wetting, and the dispersant comes to wet the particle. It's further dispersed. You see the dispersant moving and breaking further down the particles to their optimum size, and the dispersant stabilizing the different particles away from each other. So that's the process of dispersing. Deformer are needed in this process. Thickener can be added also to thicken a little bit the dispersion to avoid the cementation of the particle to the bottom. So this is the, in theory, it's nice animation. I'm going to try to show you a video from the lab. Maybe you see it now already, I hope. It's basically, what you see is that the container is clamped, and we have put the liquids, the solvent, the water, with all the particles, so pigment and filler on top. But you can see it's quite a lot of particles to be wetted during this process. So now I'm going to start the video, and you can see on the right side we added a wetting agent. So the wetting goes faster on the right side than the left side. So this phase can be generating some dust. Some particle might not go well into the formulation. You see on the right side there's what we call a nice donut. It's a sign that the viscosity is dropped and nicely, and that all the powders are properly wetting, and the process is just more efficient and faster. I'm going to move to the next slide instead of. Now, if we look at the letdown as the second phase, when we think of water-based formulation first, and we'll look at the UV formulation. Basically, I'm going to describe the coalescence process. So you can think of as soon as the wet coating is applied, basically you have a polymer droplet, which are still in water. It's often an emulsion. And then in the second phase, water will start to evaporate and the particle will come closer to each other until they start to touch each other and penetrate each other. This is a phase of compaction, which is supported by the use of co-solvent, which will soften the shell of those particles, droplets. And at the end, you will obtain ideally an isotropic polymer. So that's when you have a full coalescence. And you can see on the picture on the top right, an example of what can go wrong when you have really a poor coalescence. We call even this kind of mud cracking, where you don't have a film, it's just all broken and very brittle. On the right side, it's a full film. So here is for the binder. Now we can look at the very different process in terms of how to obtain the coating during the UV cured technology. So basically you start from a liquid paint which contains low molecular reactive component, and it's applied most often by roller coater, and then it goes under a UV lamp, so it's very, very efficient. The photo initiator that you remember from the earlier guide formulation get activated under the UV lamp, and some free radical will start the polymerization of the acrylate double bond, and that's how you obtain a higher molecular fully cross-linked polymer. So totally different scenario without solvent is involved with very, very efficient process here. Then we can look at the rest of the formulation there was, for example, in the trim paint, wetting agents. The role of the wetting agent is basically to reduce the surface tension of the liquid. As on the right side here, you see a droplet. It has a high contact angle when it touches the surface. And with the additive, so it's with the surfactant, this one reduces surface tension and basically allow to lower this contact angle to obtain a proper wetting. So you can see the effect on the right side on the picture with the two wood panel. One is very smooth with a smooth finish, proper wetting, and you can see on the one underneath a lot of what we call craters. So those are parts where the substrate is not wetted properly. Could be due to the surface tension being too high, due to the presence of some traces, residues, oily material, or living defects on the surface. Another example on the next slide, the defoamer, also very important. They are often used in the grind as well as in the letdown. So they function by basically incompatibility. So they are very hydrophobic material. So the more hydrophobic, the more effective they are to go and target the air bubbles, which are trapped in the coating. But the more hydrophobic, the more incompatible they are, the more they tend to create defect. So that's a little bit tricky. It's important to find the right balance between effectiveness and compatibility. So they are very hydrophobic. They are surface active material. They will act at the air bubble surface. They are very limited to no solubility at all, which is very critical in clear films or very thin films. And here is a list of typical ingredients that you can find in such a defoamer formulation, the actual formulation. So siloxane or mineral oil or natural oil, some emulsifier if it's an emulsion, which are often a lot easier to incorporate, and some solid particles to help the defoaming. Another important and complicated additive, the rheology modifier. So through the lifetime of a paint, a lot of different shear are applied to the paint. So from the production with a high level of shear to the storage, to transportation, especially during application, a lot of shear are applied if you roller or spray a paint. While when it's on the wall, then of course there's no shear applied anymore. But then the leveling, for example, is important, and therefore you need to use often a combination of rheology modifiers to be able to cope with those different level of shear which are applied. Often for a paint, pseudoplastic, you can see on the curve on the right, the viscosity curve of the pseudoplastic is typical for a paint. So high viscosity in the low shear and reduced viscosity when you start applying, mixing, and so on. Newtonian behavior is important also during grinds. Often we would use a real demodifier of providing such a behavior. And the last slide, another step in the formulation, the tinting. If you've been buying, for example, some bucket of paint to repaint your wall and you ask for a certain shade, maybe you've seen the person who helped you preparing the paint. So basically we have a base paint which is typically white and then pigment concentrate is added. That's what you can see on the second picture on the top right. And then it's shaped like in a Scandex shaker, and ultimately you get the shade that you wanted, desired. But there are a lot of challenges in terms of formulation behind this, in terms of compatibility between the base paint and the different colorant. Of course, you ask for one color, but there are multitude of different colorants which need to be compatible with the different base paint which are offered. It's important to obtain the right color, of course, and the right viscosity. And this in time, that means that after 6 months, you still hope to obtain the same color and the same level of viscosity. And there in terms of formulation, yeah, it's important to have a stable system, and additives there can help as well. So that's in a nutshell what I wanted to give you as some insight for the part on formulation. So thanks for that, for your attention. And I will then let the word to Erin, who will continue with the tray manual paint testing.
Thank you so much, Christine.
You're welcome.
I'm going to stop your screen share. So yes, please keep in mind to address questions to Christine in the Q&A if you have any, and at the end of the webinar, we will hopefully have enough time to answer all of them. So our next speaker is Erin Elik from Organic Chemia in Turkey. Erin is a technical solutions manager where he specializes in technical services for water-based polymer emulsions in the paint and coatings industry. And he actively contributes to the development of products tailor-made to market demands, but also taking a lead role in innovation projects. Erin designs and conducts technical trainings. He represents the company at international fairs and seminars, but he also links his tasks to market demands with R&D actions. Please take it away, Erin. Thank you.
Thank you, Tusika, for the nice introduction. I will present my screen first. Please confirm when you see my screen. And I switch to presenter mode. Can you see full screen now?
Yes, thank you very much.
Thanks again. Welcome, everyone. This is our second session in today's webinar. My name is Erin Elik, as Tusika mentioned, and I'm working as a technical solutions manager at Organic Chemia. First, I would like to thank Christine for the first session, for her insightful informations. Now I will continue with the introduction to wall and trim paint testing, and I will focus on the standards and testing methods that are really important for the evaluating the quality and the durability of the conventional or bio-based coatings for wood and decorative wall applications. When we start with the agenda, I will start with an overview of the EN 13300 standards for wall paints, followed by the detailed examination of the key tests, including scrub resistance, hiding power, gloss levels, and the grain size. We will also explore the ISO standards for the trim paints testings with the tests such as weathering, water permeability, adhesion, hardness, and chemical resistance. Let's begin with the EN 13300 standards. These standards including a wet scrub resistance, contrast ratio, gloss level, and the grain size. These are the crucial as they classify the interior wall paints into performance categories, and they are ensuring that all products meet the highest quality benchmarks essential for the customer satisfaction and the regulatory compliance. In the wet scrub resistance test, we follow ISO 11998, and we aim to measure the durability of the wall paints against cleaning and scrubbing according to this method. The test is critical for assessing of the maintenance characteristic of the interior paints. A paint panel is prepared by uniformly applying on the surface of the PVC panel, and after it is dried under controlled conditions, it's generally 4 weeks drying at room temperature, and afterwards it's subjected to a specified number of wet scrub cycles on the machine which is shown on the screen. Our evaluation includes assessing the changes in weight and the appearance of the paint, particularly focusing on the scrubbing resistance and the cleanability. And after the evaluation, we measure the gloss loss from the paint. Scrub micron loss on the thickness is measured after scrubbing, and paints are categorized from class 1. This is demonstrating less than 5 micrometer of loss, indicating the highest resistance. To the class 5 with over 70 micrometers loss of after fever cycles, it's showing the lowest resistance. This classification helps guide customers in choosing robust and maintenance-friendly paints. Our testing for the hiding power, in other words, contrast ratio or opacity, it involves evaluating the opacity of the paints based on the ISO 6504-3. Opacity is a crucial quality character, and it's affecting both aesthetics and functional aspects of the paint. During the test, the paints are generally applied on the black and white charts and to achieve the specific wet film thickness. The samples are then cured under controlled temperature and the humidity, and afterwards a spectrophotometer is used to measure the contrast ratio. We generally classify the paints based on this ratio, with class 1, which is having a contrast ratio of 99.5% or higher. That's indicating the excellent coverage of the paint. And classes descend to class 4 and 5, which means where the contrast ratios falls below 95%. It's showing a lower coverage and the worse performance in terms of the coverage. These tests allow us to refine the paint formulations to meet the precise opacity requirements and ensuring the superior coverage and the quality. In the gloss in assessing the gloss levels, as per the ISO 2813, we are concerned with the reflective properties of the paint, which impacts its visual appeal and the suitability for various applications. The test involves applying a 75 micron thick wet film on a glass panel to ensure the uniformity. So there should be no particles on the surface. The surface should be even. And after occurring in the controlled environment, we perform gloss measurements using a gloss meter, which is shown on the slide. This device takes readings at generally we focus on, it takes reading 3 angles, but generally we focus on the 60-degree angle, and the other degrees is from 20 degrees and 85 degrees. And for the 60-degree angle, we classify the paint into various gloss levels. And high gloss, which is ranging from 70 to 85 gloss units, and semi-gloss paints is from 35 to 70 gloss units, and low gloss or matte paints are varying from 10 to 35 gloss units, and very low gloss, which is deep matte, the gloss level is below 10 gloss units. And this classification is vital for ensuring that the paint meets aesthetic standards and performs as expected in different settings. The grain size, the largest grain size test categorizes the paints based on the size of the material grains, which influences the paint's texture and the application characteristics. The test starts with a representative sample from the batch of the paint. We then use the appropriate techniques like microscopy or sieving, depending on the range of the grain sizes. The paints are categorized from fine, with the grains up to 100 micrometers, to a very coarse, with grains exceeding 1.5 millimeters. And this classification is really essential for determining the paint's suitability for specific applications, impacting both manufacturing decisions and the quality control parameters. When we focus on the trim paints, these are used primarily on wood surfaces, both inside and outside of the buildings. To ensure these paints meet our strict durability and the performance criteria, we adhere to several ISO standards, which is shown on the screen. Today, we will cover the tests including artificial weathering, water permeability, adhesion, pendulum damping hardness, and the chemical resistance. Each of these tests is really crucial for verifying that trim paints can stand environmental challenges and maintain their integrity over time. The artificial weathering test, it's conducted according to EN 927-6, which is designed to simulate the long-term effects of sun exposure and moisture on the exterior wood coatings. In this test, coated samples are subjected to cycles of UV light, moisture, and the rain or spray to mimic the natural weathering. The purpose of this test is to assess the durability of the wood coatings under accelerated conditions. It's providing an insights into how the paint will perform over years of the exposure. This is crucial for the manufacturers to develop coatings that can stand harsh environment, and for customers seeking products that offer long-term protection for their wooden structures or buildings. The next test is a water permeability test. We are making a test according to EN 927-5. The test measures how well a coating can resist water penetration. It's an essential property for any exterior wood coatings. We prepare wood panels by applying 2 coats of the paints and the rest of the surfaces are sealed with the two-component epoxy. After the conditioning of the panels to stabilize the moisture content within the wood, the panels are immersed in water for 72 hours, which is 3 days. We then measure the water uptake in grams per square meter. And this test is very important in ensuring the coatings provide an effective water resistance, which helps wood surfaces last longer and stay strong when they are outside. The adhesion quality is critical for the performance of any kind of paint. The crosscut adhesion, we follow the ISO standards, which is 2409, and it evaluates the strength of the bond between the paint and the substrate. The substrates can be such as wood, metals, or plastics. After a uniform paint application and through drying and under the relative conditions, we perform a crosscut with a specific pattern and apply a tape over it, and the tape is removed quickly to see how much paint remains on the surface or attached to the tape. And this test is crucial as it measures how well the paint adheres under stress. So influences both the aesthetics and the functional durability of the coatings. For the evaluation of the paints, according to the standards, 0 means no paint is removed from the surface, which is a good, and 5 is more than 65% of the paints from the surface is removed, which is a bad quality. The pendulum damping hardness test is based on ISO 1522. It is assessing the mechanical hardness of the paint surfaces, which is indicating their wear resistance and the durability. For this test, we use either conic or pendulum, depending on the expected elasticity of the coatings. The pendulum is set in a motion over the painted surfaces, and we measure how long it takes for the oscillations to dampen. And the longer damping times indicates harder and more durable coatings. This test helps ensure that the paint can withstand physical wear and maintain its aesthetic and protective properties over time. The resistance to liquids test, it's made according to ISO 2812. It evaluates how well different coatings withstand exposure to the various liquids such as water, solvents, oils, and thicker substances like gels. And we apply the coatings and on the surface, and we allow them to dry, and then expose them to these liquids to observe any physical changes, including fading, staining, or other forms of the damage. This test is vital for the verifying that the products can resist common spills or splashes and ensuring that they maintain their quality and the appearance under such exposures. When we finally talk about the chemical resistance for the coatings, the test is followed by the DIN 68861. It's focusing on the coating's resilience to the chemical attacks. This test includes the exposure to everyday substances such as tea, coffee, red wine, mustards, and the cleaning agents in the house. And the chemicals or stains are applied to the painted surface and left for varying durations to simulate the real-life scenarios. And after the exposure, we evaluate the surface for any visible changes, rating from the damage from 0, which is no visible change on the surface, and to 5, which is a significant change or destruction on the surface. This test is crucial to make sure that our coatings are strong enough to withstand daily chemical exposure without damaging their structure or appearance. Before I conclude my presentation, I would like to extend my gratitude to all our funding, industry, and the research partners. I also want to acknowledge the hard work of our team and everyone involved in making this webinar possible. Lastly, thank you for everyone for today's webinar and this session about the introduction to wall and trim paint testing. I hope you have learned a lot about the standards and the tests we use to assess wall and trim paints. If you have any questions, I would like to answer after the third session presented by Mr. Roland. Thank you.
Thank you, Aaron, very much. Please don't be shy. I see that there are few questions up to now, so please submit them. We want to foster exchange and dialogue, so this is a good opportunity to do so. And with this, I would like to introduce our last speaker for today, which is Roland Steinbrücken from the Remmers Group. Some of you might know Remmers through their connection to IKEA. He has a degree in chemical engineering with specialization in coatings technology. And in the past, he has worked as an R&D department manager of BASF Coatings, where he focused on wood coatings. And he joined Remmers in 2003 in the Department for Industrial Coatings, where since he has been the head of UV coatings and R&D for over 15 years. He recently focuses on technical business development in an interface position between R&D, sales, and customer demands. And Roland is going to give us a little overview of the testing of UV-curable wood coatings. The digital stage is yours, Roland.
Thank you very much for the introduction. So I will share my screen now. I hope it's visible now.
Looks good, Roland. Thank you.
All right, then let me explain a little bit about the testing of UV-curable wood coatings. At first, I would like to give a little insight into industrial UV coating for furniture. I guess most of you are quite familiar with doing some DIY painting at home. Probably a lot of you heard that there is the spray application for painting cars, for example. But when we go into furniture coating, especially when we talk about the coating process on flat wooden panels, then the main technology which is used is roller coating. So the application of the coating material is done by roller coater machines, like you see them in the picture on the right. And like Christine already explained, there is no drying process of this kind of paint. It is a pure chemical reaction. The cross-linking of the film is started by the UV radiation, and then it's a radical polymerization of acrylates. So, and to make it a bit more complicated, when we talk about roller coater application, we are not talking about one of those machines. It's a bit more complex. Furniture coating is always a multi-layer coating. So in the easiest way, we are talking about 4 application steps of a UV coating. Like you can see here in this little example, 2 times sealer and additional 2 times top coat. But it's not only the roller coater application. The general technology contains a bit more. So these two triangles, what you see here, that is standing for sanding steps on the raw wood, and as well after the sealer application. There is always a smoothing process done with the sanding paper in an automated way. In the very first beginning, it can also be a stain application. That's nothing like a coating. It's only to change the color of the wood. And then the final UV coating starts with different ways of curing. Like you can see here, in some positions, it's just a gelling or half curing. And another, we have a full curing. That is mainly because of adhesion, what is of course pretty important for a coating, like Aaron already explained. So doing a full curing after all those application steps, that would lead to a failure of intercoat adhesion. All right, so now one could ask the question, why is it so popular to work with a technology like this, even though it seems to be a bit complicated? So what are the advantages of such a multi-layer technology like you have just seen it? One big advantage is that it's a really high efficient coating technology. Just to get some feeling for it, such a typical UV line for furniture coating is running around 50 meter per minute line speed. If you compare that to spray application, what can also be done in an automatical way, there we are talking about 5 meter per minute. So production speed of such a technology 10 times higher. Another big advantage is that we have a really high degree of material utilization, because there are simply no losses of material. The UV coating material is circulating on the machine, and everything what is not applied to the panel stays in the circuit, and there is no loss like in a spray application, where, for example, not all the sprayed paint is really hitting the target and ends up on the panel. Then we do not have any emission of organic solvents, because like Christine already mentioned, those coating materials have a solid content of 100%. And even for adjusting the viscosity of those materials, for the diluting purpose, we are not using solvents. We are using reactive diluents, which are later on part of the polymer. And what we can clearly see in the furniture industry, that is a strongly rising demand for having renewable raw materials. And that was the reason for Remas to join the PERFECOAT project. So what is our job within the project? It's the testing of the bio-based formulations. And what do we have to test? The very first thing what we have to test, that is of course the application performance. Not every coating material is suitable for doing a roller coater application. Here in this little picture, you see the general working principle of such a machine. The liquid paint is in the gap between two rotating rollers. One of them, the so-called application roller, is transferring the liquid paint film to our wooden panel. And the way how this liquid paint is transferred from the roller to the substrate, that is, of course, highly depending on parameters like viscosity of the material, rheology, stickiness or tackiness, and that's what we will test if the new bio-based materials are performing in a similar good way like today's formulations based on fossil raw materials. But of course, the UV curing of the material is strongly connected to the application performance. In the whole furniture industry, as well as in other industries also, energy saving is a very hot topic. And one single UV lamp has a power consumption of 18 kilowatt. So that means it's going to be really important that the necessary number of UV lamps should stay the same, or preferably be even less, to have the possibility to run the line with a lower energy demand. Of course, it would be very difficult to convince anyone to go for a double amount of UV lamps just to be able to handle a bio-based coating material. So that means the reactivity of the new bio-based binder candidates, that is, of course, one really important thing. We need to have an equal reactivity with the bio-based raw materials compared to the fossil standard. If we have managed to coat a nice wooden panel, then one very obvious thing what we have to evaluate, of course, is if it is really a nice surface. Because in the end, when it comes to the end consumer and the decision whether to buy some piece of furniture or not, then the most important question is, of course, does it look nice? So we should have a really nice, clear and transparent surface finish, and it should not have a milky or hazy appearance. And what is also not to be underestimated, that is the touch what we have on a surface. I guess many of you have already done it when shopping furniture. You always touch it, and you want to have some feeling if you like it or not. And then, of course, we have some similar aspects like Aaron already mentioned. For example, the resistance properties of a furniture surface. For testing the resistance properties, we have chosen a special IKEA standard because that one is valid globally. Whereas each country has, of course, also some internal industrial standard, but they are not always comparable. So within the IKEA standard, we have different resistance classes. One of the biggest ones, that's the so-called R2, and you can see here what is required to pass this R2 requirement. It's an exposure to water for 24 hours. It's an exposure to liquid paraffin oil, once again, for 24 hours. Alcohol exposure of 1 hour, and coffee, once again, an exposure of 1 hour. And in the evaluation after the exposure, of course, there shall not be any damage of the surface. For example, after the contact to water, there shall not be any swelling of the wood, or after exposure to coffee on a light color, for example, there should not be any visible yellow or brown mark from the coffee. Then we, of course, also have some mechanical resistance requirements. Therefore, we want to focus once again on one IKEA requirement, the so-called fat on scratches. In this resistance test, the surface is scratched in a defined way. For the R2 requirement, we go for a 3 Newton scratch, and to get some evaluation if that scratching has broken or maybe even completely destroyed the paint film, there is an exposure to liquid paraffin later on, and that means if the paint layer has been destroyed, if it has cracked, then this paraffin oil will penetrate immediately and leave some visible marks. And these mechanical properties of the paint film, they are of course connected very closely to the general structure of the UV crosslink polymer, and therefore also to the chemical structure of the building blocks of the resin. And there we're going to find out if the building blocks coming from renewable sources can perform in a similar good way like their fossil counterparts. And that's it from my side. If there are any questions from the audience, I will be happy to answer them. Thank you.
Thank you, Roland. Thanks to all speakers for all your presentations. I hope you gained some insight into the 3 applications that we are covering within PERFECOAT. And I can see some questions in the chat and in the Q&A. I think the first one is addressed to Christine, and it says, how do you test the performance of defoamers?
Can you hear me?
Yes.
Perfect. Defoamers, you would test them if this is, for example, you want to test the creation of foam during the production of the paint. So by mixing, you would use a disperser like I had shown, and basically you would mix the paint and measure the foam height. So during the mixing, the air will be entrapped and the volume of the paint will increase. You can measure the foam height after a certain time. And you can also measure it after 5 minutes to see how the foam disappears in time. And you compare different defoamer, maybe different dosages against each other, measuring either the foam height or the foam density. If you have a density cup, that's also a common practice. If you're more looking at the foam created during the application, then you would just go and apply a small sample on a Liniter card, either by roller or by brush, or even spray a little sample and look at the defect. So whether there are foam bubbles trapped on the dry film, but also craters. I explained the defoamer. It's always a matter of finding the balance between efficiency and compatibility. So it's really important to look if there are no defect created. So there's also some way to do that in a digital way with our surface defect tool that we have online. That's but visually it's also a good way to do it in the lab. That's how we would typically do.
Thank you, Christine. I will try to group the questions a little bit, and I think the next one is also addressed to you. It is, how important is the order when it comes to formulation of incorporating ingredients?
Mm-hmm. In the guide formulation I showed, you've seen different phase. So the grind and then the let down. So that's important to respect the ingredient given in each of those phases. And basically the order of incorporation is there. So first the liquid plus the additives. So you would typically, you need to add the dispersant or eventually a wetting agent and a deformer before all the particles are added. So that the process is really optimized during dispersion. And in the letdown, they just go by the order that are given in the guide formulation that is typically provided by often the binder supplier. Being careful with the rheologies, yeah, often we do that at the end to adjust the rheology with the thickener, as it takes sometimes we would typically check it the next day and also after 2 weeks, 3 weeks, and so on. So yeah, the order is definitely key.
I see. Thank you. So I think the next question is going to Aaron. How does testing the gloss levels of paint help you decide where to use these different paints?
Okay. So can you hear me?
Yes, we can hear you perfectly fine.
Okay. So gloss levels is determining the how shiny or reflective a paint when it dries after drying. So the high gloss paints reflect a lot of light. It's making them ideal for the spaces that need a frequent cleaning because their smooth surface is easier to wipe down. So generally in this type of paints, uh, the binder amount is more than the fillers. So it's a binder rich formulation. So these type of formulations are commonly used in the kitchen and bedrooms. On the other side, the low gloss or matte paints absorb more light and are better for hiding the some stains or imperfections on the walls. So such as these kind of cracks or bumps, these kind of things, and they are mostly preferred in the living room and the bedrooms where the softer look is desirable. And understanding the gloss levels helps in choosing the right paint for the right room based on the functionality and the aesthetics.
Thank you, Aaron. I think the next question is addressed towards Roland. You mentioned the importance of haptics and touch. How do you measure the performance of such subjective variables?
In the most simple way you can think of, we just touch the surface with a couple of people and yeah, then see if all of us are of the same opinion.
Okay.
For that, unfortunately, there is no real good, objective kind of measurement, because it also can happen that two people are of a completely different opinion. One likes the touch of a surface, another one not.
I see. Is there any progress in developing bio-based interior wall paints that can be used at a larger scale? Bio-based resins, additives, fillers, or anything regarding interior wall paints? Would anyone like to take care of this one?
There are definitely some additives like deformers. A lot of deformers are available based on natural oil, so maybe not as efficient as what you could obtain with a siloxane deformer, but efficient enough.
Okay, so the next one.
I don't know, Aaron, if you can comment on the binder.
Yeah,
I think.
for the next one, I can take it. It says, what are the early results of organic versus traditionals? Mostly we are focusing on the binders, bio-based binders, instead of using a conventional fossil-based binders. We did the first tests, but there are some areas that should be improved, especially in the wet scrub resistance. The common bio-based solutions are poor in the wet scrub test and also the stain or chemical resistance test. So our consortium partners are working on this, especially for the synthesis teams. They are working on improving these kind of performance criteria, which is really essential for the wall paints.
Thank you, Aaron. I think the last one might also be addressed to Roland. It doesn't say any speaker. What is the main driver switching towards bio-based solutions? And are there any specific challenges when it comes to the application of bio-based formulations at this point?
Yeah, so the main driver that is, of course, what is driving the whole industry, like the European Green Deal, for example, which is striving for a lower climate impact, which is striving for a circular economy and things like that. Those activities have been taken up by the really big players in the market, like IKEA, for example. Yeah, the demand is definitely there, and the main challenges what we see right now, that is reactivity, for example. Many bio-based raw materials which are already available today are missing reactivity. Another quite important point is having the right balance between softness and hardness. A lot of bio-based materials tend into the soft direction. So later on, the mechanical properties are going to be some issue.
Thank you for elaborating. So I would take the last two and I would postpone all other questions to our next webinar on June 10th. So Eric is asking, replacing fossil-based products by bio-based solutions, how can you overcome the color difference and smell which some bio-based raw materials have? Maybe Christine, as you're dealing a lot with the formulation, you can tell us a little bit about it. Maybe she can't hear us. Maybe Aaron, you can take this one.
Yes, of course.
This is a little bit cut at the moment.
Oh, okay. Who is going to answer?
Go ahead.
Okay.
Please
so
start.
Actually, we did also see some problems or issues in terms of the color of the bio-based raw materials. Like, for example, for the binders, we had some issues. So of course, it should be integrated to the standard conventional paint systems. And this is another case, or we should design a paints which is similar color to these raw materials. For example, if we use a brown binder or brown raw material, we should only be limited to make the brown paints, or otherwise we are not free to make all kind of paints if the color is the issue, if we are limited by the color. And for the smell, for the moment, we don't have any issues for the smell, as we are mostly dealing with the binders. But we had some stability issues, for example, for the pigment pastes. The pigment color is shifting to the light colors. For example, for the red pigment, bio-based red, it was shifting to pinky colors. But we didn't face any smell problems for the moment.
Seems the performance of bio-based solutions is better than its sort of Well, and the last one, is there any standard or certificate for bio-based paint at this point in time?
I can also take this one. For the moment, we are applying the conventional test methods which we apply for the fossil-based paint and coatings, and there is not yet any standard or certificate for the bio-based paints, but we know there is some standards for the bio-based raw materials to assess how much they are bio-based or sustainable in terms of the carbon 14 measurements. But for the paint, we are just using the conventional standards.
And maybe a nice solution to also attend the next webinar, where our expert Kamal is going to give you an overview of sustainability measurements and certification indicators. So might get a little bit more in-depth visions over there. So I would like to thank all speakers for today for your time and for preparing these great presentations, to all participants. And as always, we will make the slides available afterwards at the PERFECOAT website. And we hope to see you back on June 10th for the next episode. Thank you so much. See you soon.